this chapter is about the sequence and different types of progressions. A sequence or a progression is a mapping of the numbers, and the elements, let's suppose we denote them by the x, are called the terms of the sequence. If x is equals to r, we have a sequence of real numbers. If x is equals to c, we have a sequence of complex numbers. So as you can see, r is denoted for real numbers and c is for complex numbers. Then we have series, which is a sequence of numbers. If the numbers of terms in the series is infinite, it is called a finite series. Otherwise, it is called an infinite series. Then we are starting off with the first progression, which is the arithmetic progression, and the nth term of the progression is given by a plus n minus 1 into d, and the nth term of the AP from the last term is given by the formula as you can see on the screen. And there are also different formula for getting the nth term of the progression. There is also n, a, l, and d as you can see on the screen, where n is the nth term of the progression, while l is the last term of the progression, and a is for the first term of the progression. Then we have d, which is the common difference of the AP, and we can get it by subtracting tn minus 1 from tn. And we can also get the n term by subtracting sn minus 1 from sn, which is the sum of the number of terms. And there is also arithmetic mean, which is between a and b, and is a is equals to a plus b divided by 2. The sum of the number of arithmetic mean is between a and b is equals to n into a. Then it shows how we can get the 3 terms in AP and how we can get 4 terms in EP and 5 numbers. And it shows the method of how we can get it, like a minus 2d, comma a minus d, and further onwards. At last, we have the properties of arithmetic progression, like if the same number is added to each term, then the resulting sequence is also an AP having the same common difference. And if the same number is subtracted from each term of the AP, the resulting sequence is also an AP having the same common difference. And then if each term of an AP is multiplied by the same number, like for example variable k, the resulting sequence is also an AP. Here common difference is equals to k times the original common difference. And if each term of an AP is divided by the same number k, the resulting sequence is also an AP. Here the common difference is equals to 1 over k. Okay, so next we have geometric progression, where the n term is given by arn minus 1, and the n term of the GP from the end is given by the formula. And r is the ratio between the two consecutive terms in the progression. Then we have the sum of the n terms, and there are 2 different formulas for when r is less than 1 and when r is greater than 1. Or we have also another formula for that, when last term known. Then we have sum to infinity, and it is to known that the sum of infinity only exists when ratio is less than 1. If it is greater than equals to 1, then it does not exist. Then we have geometric mean, which is given by the formula under root AB. And the product of n number of geometric means is given by GM. Then we have shortcut methods for recurring decimals. As you can see below are the 3 examples given to you. The one is 625, other is 423, and the last is 1.245 decimal number. Then we have method for recurring decimals, like for example, step 1, the number of the vulgar fraction is obtained by subtracting the non-recurring figure from the given figure. Second, the denominator consists of as many 9s as there are recurring figures and as many zeros as there are non-recurring figures. Then we have how to obtain three numbers in the geometric progression. As it can be seen that how we can obtain these numbers. Then we have how to obtain five numbers in a geometric progression. Like for example, a divided by r squared, a over r, a, ar and ar squared. Then we have how to obtain four numbers in the GP, and as it shows how. Then we have harmonic progression, which is another type of progression. Like for example, if 1 over a and 1 over b and 1 over c are in ab, then a, b, c are in hb. As it says that here AB is corresponding to the HB, as the terms in AB are simply the reciprocal of the terms in HB. Then we have how to get the nth term of the HB when the start is given, and it is given by the formula Tn is equals to 1 over 1 upon A1 plus n minus 1 into 1 over a2 minus 1 over a1, and it shows the simplified version of the formula. Then we have how the n term of the HB is given by the last term of the harmonic progression, and the formula is simplified to the 1 over first term of AP plus 1 over last term of the arithmetic progression. Then we have the harmonic mean H between a and b, and how it is equals to 2ab divided by a plus b. And then it is to be noted that the sum of the harmonic progression does not exist. Hence, we cannot take out the sum of the terms on the harmonic progression. As previously, we could calculate the sum of the number of terms in the arithmetic and geometric progression, but that's not the case in the harmonic progression. Last but not the least, we have the sum of various series, like for example the AP-GP like combined series, and it is also to be noted that if A is greater than G and G is greater than H and AH is equals to G squared, then they are in geometric progression. And that is the end of the chapter.